So the next operator is bitwise operator. This is 8th one. These operators works on bits. So C supports the following bitwise operators. We have the 5 types of bitwise operators. The first one is bitwise AND, which is represented by ampersand symbol, and next bitwise OR, bitwise NOT, and left shift operator. This is represented by 2 less than symbols, and right shift operator. This is represented as 2 greater than symbols. Now let's discuss all of these operators one by one. So these bitwise operators, it works on the bits, and whereas in the logical it returns either 0 or 1. So the differences between the logic operators and the bitwise operators is the in logical operators it returns either 0 or 1, but in bitwise operators it will return any other value, but this works on the bits, nothing but it works on the 0 and 1. Now let's discuss all of these operators one by one. First let's discuss the bitwise AND. In this bitwise AND, the first A and B, in this first we take the 0 0 and 0 1 1 0 and 1 1. So here whenever the bitwise AND operator returns 1 if all the given bits are 1. So when A returns 0 and B returns 0, the bitwise AND of A and B returns 0, and when 0 and 1 it returns 0, 1 0 it returns 0, and 1 1 it returns 1. So it states that bitwise AND operator returns 1 if all the given bits are 1, otherwise it returns 0. It means in other cases it always returns a 0. Now let's see one example on bitwise AND. First example, first I am taking the A value as 5 and B value as 4. So it works on the bits. First we have to find out the binary number of 5 and binary number of 4. So to find out the binary number of 5, first we have to take the LCM of 5. Now 2 2s are 4. So we should always divide this with the 2. We have to do with LCM only with the integer 2. Now 2 2s are 4. Then 5 minus 4 is 1. The remainder is 1 here. Just write the 1 here. Now 2 1s are 2. So when we divide this, when we multiply 2 into 1, we get it as 2. So the remainder is 0. Now just we have to go from the down to the up. So what we got the number as 101. So this 101 is the binary number of 5. Therefore the binary number of 5 is 101. Now similarly we have to find out the binary value for the 4. So when we find the LCM of 4, so 2 2s are 4, the remainder is 0, and 2 1s are 2, the remainder is 0. Now we have to go from the below to the upwards. So we get number as 1 0 and 0. So that is the binary number for 4. Now the binary number of 5 is 101 and the binary number of 4 is 100. Now after getting the binary number, now take the binary number of 5, that is 101, and take the binary number of 4, that is 100. Now after that we have to find the 5 ampersand 4, nothing but 5 bitwise and 4. Now for that 1 0 means first for example A is 1 and B is 0, then A and B returns 0, and if A is 0 and B is 0, then A bitwise and returns bitwise A bitwise and B returns 0. Next if both are 1 it returns 1. Now we got 1 0 0. Now after getting this, so this is the place for the 2 power 0, and this is a place for 2 power 1, and this is a place for 2 square. So we have to write in the bits. Now after getting this, we have to multiply this 1 with the 2 square. So 0 with 2 power 1 and 0 with 2 power 0. So here now this 1 is multiplied with its place 2 square plus 1 into 2 power 1. So 1 into 2 power 1 plus 0 into 2 power 0. So 0 into 2 power 0. So 1 into 2 square, that is 4, plus 2 into 1 is 2. Sorry, this is 0, and 0 into something is always 0, and plus 0 into 2 power 0 is also 0. So finally we got it as 0. So this value is 4 plus 0 is equals to 4. So therefore 5 and 4, that value is 4. Whereas in logical operators we get answer either in 1 or 0 or 1, but in the bitwise operators we can get any integer value. Now let's see the example 2. A value is 4 and B value is 2. So similarly we have to find out the binary number for 4 and binary number for 2. So binary number of 4 is 101, sorry 100, and binary number for 2 is 10. Now 4 is 100 and 2 is 10. Now the 4 is 100. Now 2 is just this place is empty, so fill it with 0. Now after getting 0, 0, 1, 0, the binary number for 2 is 0, 1, 0. Now after that we have to find out the 4 bitwise AND of 2. So 0, 0 is 0. When two statements are 0, then it returns 0. If A is 0, bitwise AND of B is 1, then it returns 0. Then 1, 0, also it returns 0. Now after getting all this is a place for 2 power 0, then 2 power 1 and 2 power 2. Now after getting this, 0 into 2 square plus 0 into 2 power 1 plus 0 into 2 power 0. So everything we will get it as 0 because all zeros are multiplied with them. Now 0 plus 0 plus 0 is equals to 0. Therefore 4 bitwise AND of 2 is equals to 0. This is the way of solving the bitwise AND. Now let's discuss the second type of bitwise operator, that is bitwise OR, and this is represented by one mod symbol. Now the A and B expressions we have taken are the statements. So if A and B both returns, then A bitwise OR B returns 0. Now with 0 1 it returns 1, 1 0 it returns 1, and 1 1 it returns 1. So here the statement bitwise OR operator returns 1 if any bit is 1. In A and B, if at least if any bit is 1, then it returns the 1. Otherwise it returns 0. This is about the bitwise OR. Now example 1 for the bitwise OR, A is 5 and B is 2. Now 5 is 101 and 2 binary number is 012. Actually it is 10, but we can replace this with a 0. Now 5 bitwise OR 2. Now 1 0. In the bitwise OR, if at least one, if any bit returns 1, then bitwise OR operator also returns 1. So 101, 010, 011 and 101. Now the places we have to write. So 2 power 0, 2 power 1 and 2 power 2. Now just we have to multiply all these numbers. 1 into 2 square plus 1 into 2 power 1 plus 1 into 2 power 0. So 2 square into 1, that is 4 into 1 is 4, plus 2 power 1 into 1 is 2, plus 1 into 2 power 0. 2 power 0 value is 0. So when it multiplies with 1, it becomes 1. So that equals to 4 plus 2 plus 1, that is 7. So the value for 5 or bitwise OR 2 is 7. Now the example 2 for bitwise OR is A is equals to 6 and B is equals to 4. Now we have to find out the bitwise A bitwise OR and B. Now the binary number for 6 is 110 and binary number for 4 is 100. Now 00 it returns 0, 10 it returns 1 and 11 also it returns 1. Now we have to write the places. So 1 into 2 power 2 is 4, 1 into 2 power 1 is 2, 0 into something is always 0. So 4 plus 2 plus 0 is equals to 6. So 6 is the value for the 6 bitwise OR of 4. This is about the bitwise OR. Now let's discuss about the third type, that is bitwise NOT. So here only we'll have the one statement. If it returns 0, then bitwise not returns 1. If it returns 1, then if the bit is 1, and then it returns 0. So it's the statement. It returns 0 if the bit is 1, and it returns 1 if the bit is 0. For example, if we take A as 5, now 5 binary number is 101. Now bitwise not of this. If it is 1, it returns 0. If it is 0, it returns 1. So 1, it returns 0. 0, it returns 1. And for 1, it returns 0. Now just we have to write the places for each of them. So 2 power 0, 2 power 1 and 2 power 2. Now we have to multiply and do the sum. So 0 into 2 power 2 is 0. 1 into 2 power 1 is 2. Plus 0 into 2 power 0. 0 into something is always 0. So 0 plus 2 plus 0 is equals to 2. So this is the binary, this is a value, bitwise not value for the 5. Now the fourth bitwise operator is left shift operator, which is represented as 2 less than symbols. Now let's discuss about this operator. It is used to shift the bits to left side one by one positions. So the bits are shifted to the left side, and it takes the following form. So this will be in the form of n and the left shift operator, then x. So where n is the given number and x is the number of times the bits are shifted to left side. So it depicts the times. And let's see an example. Example 1, 4 less than 1, nothing but 4 left shift operator, left shift 1. So 4 is the given number and 1 is the number of times move on to the left side. So on to the left side only one time we have to move. So for the 4, the binary number is 100. Now for the binary number we will have the bits like 100. So this 0 is for 2 power 0, 0 is for 2 power 1 and this 1 is for 2 square. So like this it gone continued like 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7, 2 power 8 and up to 2 power n. It can be of any number, but for 4 we have only 3 bits like 100. Now 4 left shift operator 1. So this left shift operator is used to shift the bits onto the left side. Onto the left side we have to move. Now this one depicts the this one is the number of times the bits are shifted to the left side. So here it is 1. So only one time we have to move. So first let's move it on to the one side. Now this 0 is shifted here, this 0 is shifted here and this 1 is shifted to here. Now for the 1, the place value is 2 power 3, nothing but 2 cube. Now finally it will be like, now after getting this, so this is shifted to the here. So 2 power 1, 0 will be there. And this is shifted to here, 2 power 2. So 2 power 2 we have the 0. And this 1 is shifted to the 2 cube place. Now 1 we have the 2 cube place. So this box will be empty, right? At 2 power 0, this box will be empty. So at this empty, we can keep the 0. Now keep 0 at empty position. So wherever you find the empty box, at the there you can keep the 0. Now I kept the 0 here. Now here we have to multiply this all same like we did previous. 1 into 2 cube plus 0 into 2 square plus 0 into 2 power 1 plus 0 into 2 power 0. So we get it as 8 plus 0 plus 0 plus 0, that equals to 8. So this is the value for the 4 left shift operator 1. Let's see the shortcut method for left shift operator. So in this left shift operator always gives result in the form of multiplied by 2. So nothing but like 2 ones are 2, 2 twos are 4, 2 threes are 6, so 2, 4, 6, 8, 10, 12. So it will be always in the multiplied by 2. Now the shortcut is, I am taking the previous example, 4 less than 4 left shift operator 1. Now this 4 is multiplied by 2 for one time. So we have to multiply this 4 with 2 only for the one time, because it is here it is represented as 1. This 1 represents the number of bits has to be moved to the left side. Now we have to multiply this 4 by 2 only for the one time. So I am multiplying it. 4 into 2 is equals to 8. You can also check it with the previous case. We got the same answer. Now the example 2, 12 less than left shift operator 3. Now we have to multiply. This 12 is multiplied by 2 for 3 times. So 3 times we have to multiply. So 12 into 2 we will get it as 24. Now to this 24 we have to multiply 2 again. That equals to 48. Now to this 48 again we have to multiply 2. So we will get it as 96. So directly we can multiply here 12 into 2 into 2 into 2. So we will get it as 96. So this is about the left shift operator. Now let's discuss about the fifth one, that is right shift operator. Now in this right shift operator, it is represented as 2 greater than symbols. Now it is used to shift the bits to right side bit by bit. Now in the left shift operator we move the bits to the left side, but in right shift operator we have to move the bits to the right side. So it takes the following form. So it will be in the form of n right shift operator and then x. Now where n is the given number and this x is the number of bits are shifted to the right side. Now example, if we take 7 right shift operator 1. So 7 binary number is 111. Now to this 111, just when we write the place value for each of them, so we get for the first one 2 power 0, for the one 2 power 1, and for next one 2 power 2, and this go on up till 2 power n values. Now we have to shift these bits to the right side. Now this 1 is shifted to the 2 power 1 place, and this 1 is shifted to the 2 power 0, and this 1 is shifted to the 2 power minus 1 place. So this every bit, each bit is moved to the right side for the one time, because this is 7 right shift operator to the 1. So only one time we have to move. So after shifting onto the right side, the 1 is placed at 2 power minus 1, and next one is placed at 2 power 0, and last one is placed at the 2 power 1. Now we cancel this because we do not consider any decimal point. So 2 power 1 nothing but 2 power minus 1 nothing but 1 by 2. So that equals to value is 0.5. So we cannot multiply 1 with the 0.5. So just we delete this. So whenever we get the 2 power minus negative values, we just delete them. Now we will multiply the remaining. 1 into 2 power 1 plus 1 into 2 power 0. So 1 into 2 power 1 is 2. 1 into 2 power 0 is 1. So 2 plus 1 is 3. Now the second example is 9 right shift operator to the 2. So 9 binary number is 1001. Now 9 binary number is 1001. So now here we have to shift the bits to the right side 2 times. So first we are shifting one time. Now 1001, 2 power 0, 2 power 1, 2 power 2, and 2 power 3. Now we will shift on to the right side. So now this is shifted to the 2 square, and 0 is shifted to the 2 power 1 place, and this 0 is shifted to the 2 power 0 place, and this 1 is shifted to the 2 power minus 1 place. Now after shifting, we will just sort in the boxes form. So here 1001. Now this 1, the place value is 2 power minus 1. For this 0 is 2 power 0 because we shifted to the right side. Now for this 0 it is 2 power 1, and for 1 it is 2 square. Now again we have to shift because only one time we have shifted onto the right side, but it is right shift operated to the 2, nothing but 2 times we have to do. So one time it's already completed, and one more time we have to shift. Now again shift this 1 to the right side, 0 to the right side to the place of 2 power 0, and 0 to the 2 power minus 1 place and 1 to the 2 power minus 2 place. Now at 2 power minus 2 1 bit is there, and 2 power minus 1 0 bit is there, and 2 power 0 1 bit is there, 0 bit is there, and 2 power 1 bit is there. Now after sorting here, 2 times we shifted on to the right side. So the process has completed. Now here we know that we cannot multiply with the 2 power negative values. So we just delete these 2 bits. Now the leftover are 1 and 0. Now this 1 is multiplied with 2 power 1 and the 0 is multiplied with 2 power 0. So 1 into 2 power 1 plus 0 into 2 power 0. So that equals to 2 plus 0. That value is 2. Now this is the right shift operator of 9 to the 2. Now let's see the shortcut method for the right shift operator. So for left shift operator, we multiply. The left shift operator always gives the result in the form of multiplied by 2, but here it is opposite to the left shift. So in right shift operator always gives result in the form of divisible by 2. So for example, if we take the 7 right shift operator to 1, the previous example I have taken. So when I divide 3 with 2, just we have to divide the number with 2. We have to divide it for only one time because right shift operator to the 1. Now when I divide the 7 to the 2, so 2 3s are 6. So the quotient is 3. When I divide, I get the remainder, I get the quotient as 3. So this 3 is the value. You can also check with the previous example. Now the example 2 is 9 right shift operator to the 2. Now 9 divided by 2 is 4, and again 4 is divided by 2. We will get it as 2. Now this 2 and this 2, the both are same. So this is a shortcut. But if it asks in the exam, the whole process has to be written. Now the example 3, 18 right shift operator 3. And now this 18 is divided by 2. So I get 9. And 9 is divided by 2 again. I will get it as 4. So 2 times has completed. Now the third time this 4 is divided by 2. And I get it as 2. So 3 times has completed because right shift to the 3. So 3 times we have to divide. And here right shift to 2. So 2 times we have to divide. So this is about the bitwise operators. Let's see the C program to implement all bitwise operators. So first we have to include the header files. Then it starts with the main function. And now here directly I am writing the printf statement. I am just giving the inputs through the printf. Now printf bitwise and is %d, and the operator I am giving it is bitwise and, so that is 7 ampersand 2. Next bitwise or is %d. So this %d will which prints the 7 bitwise or of 4. Next bitwise not is negotiation of 5. Left shift is 8 left shift operator to the 2, and then right shift is %d, and this is for 9 right shift operator to the 3. Now get ch, after that return 0. Now let's see the output for this. So here I have given the inputs directly from the printf statement. Now the bitwise and is 7 ampersand 2. 7 bitwise and 2 is 2. And bitwise or is the 7 bitwise or of 4 is 7. And the next bitwise not is 2. Means negotiation of 5. Nothing but bitwise not of 5 is 2. And then left shift of 8 left shift operator to the 2. That E gives the 32. So just we had the shortcut for the left shift operator is we have to multiply the number 8 with the 2 times. So 8 into 2 is 16. Again 16 into 2 is 32. And the next right shift operator of 9 to the 3. So just we have to divide the 9 with the 2 3 times. So we will get it as 1. You can take the values as you want. The values can be changed here, or you can also declare some variables and you can use it as a statement. Then after that you can print the I like bitwise and bitwise or and bitwise not. It's depend on you. But whenever you give it in the printf statement, the values has to be changed every time. This is one of the easy program on the bitwise operators.